All right. Hello, everybody, and welcome to the stream. Hope you all are doing well today. How is everyone? So I know we got off to a kind of a late start tonight because I had some prep work that I wanted to do and some things that I'm still sort of working out for the stream in general. However, we basically have in store for tonight, we are going to work on our scenes, or at least continue our scene work. And so I've got that outline. We're just going to kind of revisit that and see what, if anything, we can go ahead and continue on with that. So let me just adjust this microphone a little bit there. Okay. So before I jump into that, I just want to get a couple of things mentioned and out of the way. So the very first thing that I would like to mention is I would like to take a quick moment to thank all the supporters of the channel. So these are our supporters and our partners being the highest tier of support on YouTube memberships and Patreon. So those partners are Caden Parker, AR Slia, Gerbullies Inc. It looks like there might be some out-of-date ones here. There's Kyla M26, Patrick Coolman was in there at one point. Super awesome. Taco and Wen Cheng. So let me see. And then we have all these other fine people that are in this supporters list down here at the bottom. So one thing that I'm working on, and this kind of tells me that it might not completely be working correctly, is a service to sort of aggregate all of these things. And I'm not 100% sure how accurate this is. I think it's pretty accurate. I took a sample of this, what was it, 2 days ago? So it should be fairly accurate. And one thing that I do have in there is the Twitch sub. So I do have a way to actually pull that now. So I just wanted to take a moment to thank all these fine folks for their support of the channel. It allows me to do things like buy new equipment and things like that to further the development of what we do here on the channel. So other than that, I also want to take a moment to thank all the viewers. Even those of you who are not able to support it financially, you support me just by being here and following along, and I greatly appreciate each and every one of you. So thank you guys so much for being here and following along with me. So with that, one other thing I want to mention is for those of you who might be new to the stream, this is designed to be an interactive stream. So if you have any questions, comments, concerns, anything like that, or just want to chat, feel free to drop your comments and whatnot in the chat, and I will do my best to respond to them accordingly. So, with all that said, I'm going to go ahead and grab our outline here that we are making. And we sort of just kind of outline some of the general requirements that we're going to need for scenes. And so we actually have done this, turn lights into actual objects in the world. So that was one thing that we did with the new lighting system we just put in recently. So that's all up and running and good to go. So I'll go ahead and highlight that. Turn skybox into an actual object in the world. So we should probably take a look at that real quick, because that's kind of the next thing before we can really jump into scenes. So let's have a look at... I guess the skybox in itself is an object that we have a few resources for: texture map, geometry. There are some of these things that I would prefer that be not hard-coded. But I don't think for the purposes of actually getting scenes up and running, we need to change those things right now. I think we can kind of just use them as is. So we do have a destroy here, and we have a create. So it looks like the create also acquires resources, and the destroy releases at least the texture map resources. It doesn't look like it actually unloads the geometry. So we may need to actually handle that. Okay. But for right now, I think I'm going to kind of roll with that as is. We'll see if we can sort of shoehorn this in, and once we figure out a sort of interface that we want to have a lot of these things follow, we can do that. Hey, Nightlone. Yes, I did get myself a haircut. Actually, I did that several weeks ago, so I'm actually due for another one. I've started cutting it here at home, actually, so it's just a lot cheaper that way, you know. So yeah, I probably will be doing that this weekend, actually. All right. So let's just go back to our outline here. I'm going to turn this yellow because I don't think we need to necessarily handle this right now. Let's go with that. But we probably need to come back and revisit that at some point. A couple weeks ago, you think I watch you that often? No, probably not. But actually, it was probably closer to a month ago at this point. Okay, so generic scene interface is probably the next thing that we can start setting up. We could either start there, or we can actually start building out our non-ECS scene, which I'm tempted to actually do just so we have something up and running, and we can kind of see if this interface is truly going to work, right? And then we can sort of build the generic scene interface around that, I'm thinking, and operate that way. Because otherwise, until we at least, kind of get this, all of this put together, we're going to have to kind of change things in multiple places, which isn't ideal. So what I'm going to do is, instead of calling this a non-ECS scene, I'm going to call this a simple scene. And that'll differentiate it from an ECS scene. And that's how we're going to sort of split that up between the two. So let's go ahead and let's see, where do we want to put that? Probably under resources, because eventually we're going to have a configuration that we want to be able to load up a scene. So for right now, we're going to be kind of hard coding our scene, but we're also going to have a file format that we're going to set up to be able to load this. So I think resources is probably going to be where we want to do that for now. So if we take a look at some of our other resources, we basically have a load from resource that takes a resource name and outputs that resource. And then, of course, we have an unload. The skybox works kind of the same way, although it's kind of in between, like I said before. The UI text has a create, destroy, and a draw. So they're all kind of different, right? Which I think is okay for right now. I would say if we wind up making these things all have a common interface, we could probably just, that common interface will probably be a component that wraps this. So I'm going to go ahead and create a new file here. Let's go ahead and call it simple scene.h, and we'll just start kind of stubbing some of this stuff out. So I guess we can start with the type definition of the structure itself. So we'll call this simple scene. And for now, this is going to be fully public, right? And this will make it, I guess, unit testable, if we want to call it that, right? And if we want to abstract parts of this, we can do that later, but I'm not going to bother with that for right now. I'm going to keep this structure public for right now. So we have a couple things here that are going to be in our generic scene interface that we're definitely going to want. So we want this can be enabled, disabled. Should have a general state. So we have these various states here. These are things that we could probably go ahead and stand up for right now. So we can say state. It also is going to have a transform of its own. So that way we can sort of offset scenes and whatnot. I don't know what that will actually wind up doing that, but it'll sort of act as a root entity, if you will. So yeah, I think we can go ahead and add those things. So the first one will be, I'll go ahead and let's go ahead and put a generic or like a global unique identifier. So we'll just put a U32 ID. We don't have our defines, right? So we need that. So we have our types. We will need a scene state, so we'll type def enumeration. We'll call this simple scene state. This probably is going to be something that is going to be shared across all scene types, but I'm not 100% sure about that. So for right now, I am going to stick with this, and I'm just going to make one per scene type. By the way, you're totally going to be background noise as I get my rear kicked in the game. That's totally fine, dude. I appreciate the lurk. Thank you. Okay, so our states are going to be simple scene state. And I'm actually just going to copy this so I don't have to retype it a bunch of times. Simple scene state uninitialized. And then we have initialized. And then loading. We'll say loaded. And then unloading. And unloaded. And we'll go ahead and I guess put in our definitions of these things, right? Because I think that makes sense to go ahead and do, so that it's clear to anybody that uses this. So I'm just kind of copying these from my outline. So this means that it's been created, but nothing more. The initialized means that we have parsed the configuration. This says unloaded. I should probably say not yet loaded hierarchy setup, right? So we have that hierarchy of objects set up, but we have not actually loaded them up. The next thing we want is in the process of loading the hierarchy, right? So that's when we're actually going through that. And then loaded obviously is everything is loaded. And essentially the scene is ready to play. That is basically going to be the only state that we are going to be able to play the particular scene in, is this one right here. So if we're not in loaded state, we're not going to be performing any sort of updates or drawing or any of that kind of stuff. So the final one is unloaded. So it's unloaded and ready to be destroyed, right? And then once it's destroyed, it will flip back to uninitialized, okay? So creating a scene basically stands it up with default values for everything, right? But nothing more. So we can put here our simple scene state, and we'll just call that state. All right. The other thing that we're going to need is a B8 for enabled, right? Because we can enable or disable scenes, which will opt them into updates or rendering, right? So if it's not currently enabled, then we don't want to even attempt to render or update those things. Let me see. So I think that is mostly what we're going to need in terms of the structure for right now. Obviously, we're going to be adding the various types of objects to this, but for right now, that is good enough. So we are going to need some methods for some of this stuff, right? So let's call this, everything is going to basically return a B8. So we'll start with simple scene create. And in this case, we do want to take configuration, right? But we don't have types for that yet. So I think I'm just going to say void pointer config, right? And we're just not going to do anything with that for right now, but let's reserve it. And then we'll also say simple scene pointer out scene, right? And that is going to return a scene that is created if successful, otherwise false. I don't see any reason why we fail this, but maybe we'll come up with something down the road. So I don't want to sort of code us into a corner there. I'd rather just be flexible and allow for that. So we'll say creates a new scene using, I should say, with the given config does not allocate, actually I should say, with default values, no resources are allocated. Config is not yet processed, right? So we'll take this in steps. A pointer to the configuration, a pointer to hold the scene, the newly created scene. This is required, right? This is optional because we're always going to have the ability to create scenes in code or from configuration. So we don't necessarily want to always require a configuration. Nightlone, time for me to disappear again. That's cool, man. Thank you for stopping by. I appreciate it. All right, so the next one is going to be our destroy, right? And actually, do we need to, you know what? I'm just going to do it. I was thinking we could do just a void for that one, but I'm not going to do that. I'm just going to allow us to return a Boolean if need be. So the simple scene destroy is going to take a simple scene, obviously, pointer to one rather, and we're just going to call that scene. Nice and simple. Destroys the given scene. Performs an unload first if the scene is loaded. That's an important thing to mention, right? So technically speaking, we could just call destroy a scene and do it right then and there, and it will also perform the unload automatically if it's currently loaded. And we want to do that so that we don't run into an issue where we are allocating resources during the loading and then we destroy the scene, but we've never actually freed the resources, right? We don't want to run into that. So a pointer to the scene to be unloaded. Required. Oh, I forgot to change the return here. True on success, otherwise false. And I'll just copy pasta that down here. Okay, so that's create and destroy. The next one is going to be simple scene. Let's see what's next. I think it's going to be initialize. Yeah, initialize. And this one I think is only going to actually take the scene, right? I don't think we need to pass anything else there. So performs initialization routines on the scene, including processing configuration if provided, and scaffolding hierarchy. A pointer to the scene to be initialized. Wow, I can't type tonight. Okay, so again, true on success, otherwise false. And since we have our initialize, the next thing is load. So simple scene load, and that will obviously take simple scene again, pointer to that rather. This is largely the same, so I'm actually just going to copy this guy to save a little time. So this is performs loading routines and resource allocation on the given scene, right? Pointer to the scene to be loaded. True on success, otherwise false. Why does that say BO? I want B8. All right, next. So we have load. Obviously, we need to do unload. So that is performs unloading routines. In resource, I'm going to say deallocation. On the given scene to be unloaded. There we are. Okay, so we have create, destroy, initialize, load, and unload. That should be... That's not actually everything. So we need an update, right? So we need simple scene update. And this is obviously going to take a scene. And then it's going to take a F32 delta time. And this actually brings up something that I've been wanting to address for a while. Which is, right now, we're sort of passing this delta time all over the place, but some places need delta time. Some things might need the total running time. Some things may need the frame allocator, or other various frame-related resources, right? And right now, we don't have any way to sort of keep a hold of that stuff or any structure to kind of hang on to that, which is a problem. So I think what I'm going to do is we may actually take a small detour from this and resolve that. Because I really don't want to get too much further without having this. And I got thinking about this the other day while I was doing something else. And in fact, I'm not even going to write the comment for this yet. And it makes sense to sort of have a structure that holds the frame data for you, right? And it's something that we don't have yet, but we probably should. So some things that we're going to want are immediately our delta time and at a very minimum our linear allocator, right? So I think probably the best place to go is to go to engine.c because that's where our game loop is. So we have our engine run here, and then this is where our actual game loop is. This is where we do all of our clock updates and stuff, right? Frame start time is platform absolute time, right? Like this is everything that we basically need per frame, with the exception of the frame allocator. I believe we do have access to that, though. I think that's held in the engine state, if I remember correctly. Was it application state? Frame allocator. Yeah, there it is right there. So we really ought to be using this guy, or at least a pointer to that guy. Wait a minute. We have this app frame data. What's in this guy? World geometries to be rendered this frame. It's more like a render packet kind of thing. Are we actually using this anywhere? It's been a while since I've looked at this code. So we're zeroing the memory, clearing. I don't think we're actually using this at all. App frame data. Oh, yes, we are right here. Right. So this is an example of a thing right here that could really use this. Because we have, this is another place where we have like delta time being passed, right? And we could really use frame data being passed here. All right. App frame data. So there's some of this data that can be used by the engine, and some of this data that would be specified by the application. However, this app frame data here is actually defined in the engine, which doesn't make a whole heck of a lot of sense either, now does it? All right. So I'm thinking probably what we should really have is the engine itself should define a structure. That's, we'll call it engine frame data. And within that structure, we should allow the application to create its own opaque type that only the application itself knows or cares about, called the, I don't know, application or game frame data, right? Specific stuff that maybe the application needs to know about per frame. And that may not actually wind up being used at all, right? It would be something that we would basically cold cast at this level if we needed it, and go from there. Which in this case is kind of because we're hacking together sort of a scene by doing all this update and render stuff here. So this is kind of our chance to fix that, and I think we probably should. The other thing that I'm noticing here is we actually are dealing with our render packet here. Where else do we actually use this? So we're destroying the data right here. Where is this frame data actually used? So all we're doing, I think, is reserving this array every frame, which is terrible. Right. This is where we're doing our frustum logic, right? Which, incidentally, we could probably move that to the scene as well. So when the scene determines what actually gets rendered or not, the scene could actually be responsible for handling this. So this is some code that we can actually get out of our game that really doesn't need to be here in the first place. That potentially our scene could handle for us. So that's another thing that we could potentially fix. Now I'm actually thinking about derailing completely and fixing this, because that is slightly more important, I think. All right, so let's go ahead and start with that. I think the first thing I'm going to do is, just to get our feet wet here, is I'm going to nuke the app frame data. Because it really doesn't belong there. Let's see. So the application itself is what holds on to the frame allocator, which is also kind of stupid. Because why would the application be responsible for standing that up? The application shouldn't do that. The engine should be doing it, and the application should be... Oh, we got ads. One moment. All right, we are back. So, we were just talking about the fact that the application is actually holding the frame allocator, which kind of doesn't make any sense either. That should really be an engine level thing. The application should be able to configure it, maybe its size, right? But the engine really should be managing this. If we look for all of our references, this is actually created in the application boot sequence. And then in the update, we're doing a bunch of things here. And this is part of the game instance, which is probably why I did it there. But if it's part of our frame data that we pass, then we don't have to worry about it being stored there. So I am also going to nuke that because the linear allocator really has no business being there. Which means I believe I can remove linear allocator from this because it doesn't belong there in the first place. So we're going to get rid of app frame data, and we're going to get rid of, I'm not even going to keep these in comments, I'm just going to get rid of them. Okay, so this is the application. So the engine itself has this engine state, and this is probably where we're going to keep it. And I think, do we already have, we do not have linear allocator in here, but that's okay. We will add it. So let's go with, include memory linear allocator. We will put here, after the systems manager state, linear allocator frame allocator. Okay. And we'll go ahead and comment this. And allocator used for Toka, thank you so much for the follow. I appreciate the support. Thank you. So an allocator used for per frame allocations that is reset every frame. All right. Okay, so we have our frame allocator here. Now let's go ahead and just start kind of getting rid of some of this stuff out of the test bed. So the thing I want to get rid of here is out of application boot. There's no reason it actually has to happen there. It can happen much, much earlier, in fact. So when we do engine create, right after the memory system, let's do, so we have engine state here. That's where that's allocated. Let's do it here, right? That's where we're kind of setting that up. So we want the engine state frame allocator. We want the address of that. We should probably have some configuration for this, right? So we're allocating 64 megs for that right now, which may or may not be enough per application. We may need much more memory than that, or very, very little, right? Now we're not even, I don't even think we're coming close to that, using that all up right now. But let's see. So we have the engine create, the application. Do we have the, we have the app config right here. So let's go with application config, and we will add a new property to that. We'll go right here to, we'll just put it here at the end. So U64 frame allocator size. Okay, oops. And the size of the frame allocator. What keyboard am I using to code? So I switch it up a little bit. I'm using currently my cord is kind of short here. The Corsair, what is it? The K70 RGB Mark II. So, unfortunately, my cord is kind of cable managed to the desk, so I can't actually like lift it up and show you. But if you do take a look at my YouTube channel, there's actually a screenshot of it on the page. So if you go to youtube.com/Travis Roman and check out the banner on that, that is basically a screenshot of it right there. I also have this one. Where's the camera? Right there. So this one is the Keychron K2 wireless mechanical keyboard. So I use this one quite often as well. I'm just not using it tonight, just because I wanted the full-size keyboard, but I quite like that one as well. Yeah, Keychron. All right. So let me just convert this to one line here. All right, so now we have our frame allocator size in here, which means we should go to our testbed main and let's see. I know we have our configure render views, but I think we can just actually go to on boot. Is where we actually want to set up the config. So the application config here. We can actually put this anywhere within here. Let's put this towards the top. Let's go config frame allocator size equals, and then we'll go back to engine, grab this, slam that in there. So now that we have our frame allocator size here, we can then go back to engine and use the what was it? Game inst app config dot frame allocator size. So that way it's a little bit more configurable that way as well. Cool. So we've taken the create. We also need to have a look at the destroy. Actually, do we even destroy that anywhere? So we have some allocations happening here. These are all going to have to be changed once we set up our frame data. No big deal. Okay, not really. So that's actually an issue. We don't actually release that anywhere, which is kind of special. So since we're linear allocator creating there, when we're shutting down, we'll go ahead and do this right here at the end. Linear allocator destroy engine state, engine state, game inst, app config, it's not in there. It's the frame allocator right here. We want the address of that. Right, so that is the destroy for that. So we go ahead and clean that up, which we weren't doing before, which is bad. Okay, so now we can move on to frame data. So frame data needs to be put in some place where it's easily accessed. So let's have a look and see what all we're including in our test bed. Let's see, where could we put this? Probably doesn't really belong in any of these places for sure. Renderer types, not really. We might just... Do we create a new header file for it? Maybe like an engine types or something. we have game state, but no, that's too specific to the application. I guess the best place to put it would be, because we're not even, I don't want to have to include engine.h everywhere. That's what I'm trying to avoid. I guess we can go into core and let's do core, create a new file, frame data.h. I was trying to avoid putting it in something of its own, but I think it kind of makes sense. It doesn't really make sense to put it anywhere else. Is your VS Code themed, or is it just the default? It is themed. So I have the Groovebox Dark Hard theme, which is this guy here, right there, right? So that's the theme I'm using. You can get it from the extension store, right? Let me actually get rid of some of this stuff so we have more coding space. So we want to obviously include our defines, and we're going to type def a new struct that we're going to call frame data. Surprise, surprise. And this is going to include, first and foremost, F32. We'll call this delta time. So this is going to be brief. The time in seconds since the last frame. We're also going to have F32 game time, or maybe we should call that total time. The total amount of time the application has been running. Oops. This should be the total amount of time in seconds, right? Because that's what we deal with here. And that's going to get to be a pretty big number. So I'm actually going to increase this to an F64 or a double. Let's go ahead and we will we're going to say struct linear allocator, right? And we're doing this because we're basically forward declaring this struct linear allocator frame allocator. And this is just a pointer to the frame allocator. So brief, a pointer to the engine's frame allocator, right? So it's owned by the engine, but we're given access to it through this frame data structure here, okay? And that way it's easily accessed from anywhere in the application. And eventually we'll fill this out more, but I think that's probably sufficient for right now. So frame data, I'm probably also going to pass frame data as a constant pointer around, simply so that we don't necessarily have to copy that data for everywhere that we pass it. And we never should be modifying it. The only thing that should be modifying it is the engine. So I think I'm going to also have the engine just hold on to that, right? So I will put in here include core frame data. And then we will say frame data. What do I want to call it? Because it's frame data, right? Frame. I don't want to call it frame data. I call it frame, I guess. What do I want to call that? Let's rename frame data to frame info. Wow, that did nothing. Okay, sweet. I love when refactor fails. Okay. We'll call the structure frame. I don't like that either. Naming is difficult sometimes, folks. Frame data, I think, makes sense. I guess we could just call it P frame data, wherever we pass it in. I don't really follow that naming scheme all that often, but I guess it makes sense here. So P frame data. I guess that'll work. Two hardest problems: naming things, cache invalidation, and off by one errors. Oh my god, you're not kidding about the off by one errors. Story of my life. Absolutely. Okay, so there's our frame data. That will be automatically initialized to 0 when we go ahead and stand up this. So all we should need to do is, once we've created the linear allocator, we'll say engine state frame data, p frame data rather, dot frame allocator is equal to the address of the engine state frame allocator, right? And now we have that set up. The other two things will be zeroed out, so I'm not going to worry about setting them. That's the main important one. Okay, so this is all the boot stuff. We shouldn't have to worry about that. Most of our updates are going to happen here in engine run. So we have a clock start and a clock update for the engine state clock. The current time is here. And we're saving off the last time and getting... Okay, so the current time is going to be the total elapsed time on our engine clock. So that is where we're going to be updating our frame data, right? So we have our delta and our current time here. So engine state p frame data dot total time equals current time, and that is already an F64, so we're good there. Technically, the delta time is in F64. I don't know if I need that much precision though. See, we're casting it to an F32 here. I really don't think. Yeah, I mean, it's not going to be tons of seconds since the last time anyways, so I'm just going to stick with that. P frame data, and then we'll go with delta time equals F32 delta. All right, so that data is being updated here. Now, before we can actually move on and do anything else, we actually do need to take another piece out of our testbed main, which is going to be our update, because we are actually doing the frame allocator reset here. So that's got to happen sooner. And clear frame data, I'm going to comment that out because we might want to actually do that if we have specific frame data for the application, which reminds me, we haven't actually set that up yet, but we can come back to that. So the engine, we'll just say linear allocator free all, and this is going to be the engine state frame allocator, right? The address of that. So we reset the frame allocator here, and then we can go and update our systems, some of which will wind up using that. And our systems manager update takes a U32 delta time. Why did I say U32 there? That should be an F32. That's a major bug. what is the update? Yeah, this is an app. Oh man, I can't believe that. Well, I guess it'll just convert back and forth, but that's gonna, oof, okay, that's really bad. Need to fix that. So systems manager updates. That, instead of taking a delta time, needs to take frame data, right? And that's gonna be constant p frame data. And that's gonna be a constant pointer to the current frame's frame data. Frame data. The data for this frame. I'm going to wind up typing that a bunch of times, I have a feeling. Okay, so at this point, we can actually just, instead of including... Why is this include linear allocator? Oh, because of the systems allocator. Okay, that actually does make sense. Okay. Yeah, let's do construct and just for declare this so that we don't have to add any more includes. I'll do that there. All right, so now we have struct frame data. We're taking in our frame data here as a constant pointer. Let's go to systems manager update. Get rid of this delta time. And now we actually need to update our systems function pointer to actually take this. Okay, so we're going to have to step through all of our systems and update this, which is kind of sucky, but at the same time, it's something we should have probably done a while ago. So the systems manager, again, this is going to just be the same thing here. So that shouldn't be any problem with that. And then this is going to be p frame data, right? And then anything that implements that will have to be refactored as well. Let's see. Not sure that anything else here actually uses that, so I think we're probably good as far as the systems manager goes. Now, we are going to have a problem with the actual systems themselves. So we're going to have to change that up for all of these guys, basically. So we'll just start at the top and work our way down. Well, actually, we only need to do this actually for systems that have updates, so it's actually not all of them. So this one doesn't have an update. Oh, you know what? We can actually do it this way. We actually have all the function pointers in here, right? Because we know we register our known types. So anything that basically provides this last one here is what we're going to wind up using. So we have initialize, shutdown, and then update. So initialize, shutdown, update. Memory is the only one that does not provide initialize. So not that one, not that one. None of these ones are actually going to need it, which is awesome. Actually, I don't think any of the pre-boot ones need it. Except the job system. Job system needs it. Hey Ben, how's it going? Good to see you. All right, so we're going to do job system updates. Let's update that here first. We'll also need to forward declare that guy. So I'll do that here. Just like that. So we have our frame data. And yeah, that should be fine for that. The job system C needs to be updated as well. And that is going to have to include core frame data, right? And now from that frame data, do we actually, I don't think we actually need it here. It's just including it just because. Because it's got to meet that interface, right? So I don't think we actually have anything in here using it, which is fine. I suppose we didn't have to do the include. We could have just left it as is, but at least now if we change it, it's there. All right, so let's go back to Systems Manager. So that's job system. Here's the shutdown. So let's go look at the post-boot ones. And again, there's not going to be too many of these that have updates. Actually, I think that's all of them. The only other thing is the render system, I think, has it, doesn't it? You know what? Let's go ahead and build. Just see what we get. Passing argument to parameter pframe data here. What is this bleating about? Oh, right. Systems Manager update. It's not actually passing the thing. We forgot to actually update that from the top. So we need the address of engine state, pframe data. Let's build that. I'm sure there's going to be other errors. Yep. And also, we're going to have to update this too. All right. What is all of this? Oh, right. Yeah, the testbed main. Yeah, that's not. I'm not surprised that's broken. So, oh, it did build the engine and whatnot, so that's cool. But let's finish up our engine changes, and then we'll come back and make our testbed changes. So I'm going to go back to engine. And let's just see the different places that we're passing delta. So this is another example of like where we're passing this render packet. We're like keeping another copy of delta time in there, and we don't really need to do that anymore. So render can also get changed to take in the frame data as well. I think that might be, oh, an input update. Okay. Okay, so not too much, not too bad. All right, so we'll go here to game instance and we'll update this first. So this is in application types, which I don't think actually has this structure declared. So let's do this, right? Forward declare that essentially. And we'll have our update and our render. Take both of those things. The render packet and frame data are going to they kind of overlap at the moment, but we're going to be changing that as well. Render packet has delta time. We'll get rid of that. All right. Okay, so pframe data, a constant pointer to this frames, no, the current frames data. And we're going to put this here as well. So we've got that, which means our engine is going to have to change. Instead of passing F32 casted delta, we are going to pass the address of engine state pframe data and the address of engine state pframe data. We can also get rid of this because the render packet's no longer going to have that. But anything that's using this is going to be able to have that. All right, so there's that. Input update needs to be addressed as well. So this technically is a system all of its own that technically does have an update. However, we don't have the system manager update doing this because it has to be called at the end of a frame. So I'm actually going to take this out because this is actually, let's put a note in here. Does not use system manager update. Because it must be called at the end of a frame, right? We'll go ahead and pass in our structure here, our frame data. So this will be a constant pointer to the current frames data, right? We are probably also going to have to forward declare this, I think, because I doubt this has that type up here where it's included, which it shouldn't be. So we'll just do that right here. Right, so we have the struct frame data there. So that means our input update in our C file just needs to be adjusted. See, we're using X64 here, F64 rather. And the problem with that is, you know, all these inconsistencies, that's what leads to bugs, right? So if we're just passing this structure around that has all this stuff in it, then we don't have to worry about that. So frame data we need to include here. So include core frame data. So that way we can pull that out if we need to. Let's see. Updates. I don't know if anything actually has to use this or not, though. I don't think so. I don't think there's any sort of timing in here yet. So once again, you know, we probably didn't have to include that because we're not using it, but I'm doing it anyways, just for the sake of being consistent. So to our input update, we need to pass the address of engine state pframe data, right? So that's the engine updates. Now it's definitely going to bleat once we get to the game code. Render front end, not surprised that's actually bleating. So let's take a look at that. Because this is actually looking for the packet delta time and it no longer has that. So the renderer draw frame is just taking the render packet, which is definitely not right. So let's take a look at renderer draw frame, render front end. That's being called by the engine. That is only taking the packet right now. That should be taking also the address of engine state pframe data. Frame data. Okay. Which means we're going to have to go here to the header file. And we'll put that there. Pframe data is going to be a new parameter. Oops, param. A constant pointer to the current frames data. Right. Let's go ahead and recopy this. Go to the top. We are going to forward declare this again. Okay. That's the H file. The C file just needs to have that pasted. Come in here to core and include frame data. All right. And now all we have to do is take the pframe data. And I think delta time is already called delta time, or is it just delta? So the renderer plugin interface has to change too, because technically that should just take pframe data. So I'm going to do that. And pframe data here for the end frame. And we need to make sure that that fits all the way through. So we're going to break our Vulkan plugin for a second here too, but that is the way the cookie crumbles sometimes, folks. So we're just having the delta time there now. This is render types, so I guess the render plugin should I put it? Yeah, I'll put it all the way here to the top. So we'll forward declare this, right? We're just kind of following the same pattern here, right? So we need the begin frame. This needs to take a constant pointer. The end frame also needs to take a constant pointer to that. So instead of this, it's going to be p frame data. Memphis, thank you for the follow. I appreciate that. Constant pointer to the current frames data. All right. So we've got that. Try and keep our comments up to date here. All right. So we're going to have to change the Vulkan plugin as well, but that's not a huge deal. So that just takes p-frame data as expected. The engine should build now. However, the Vulkan renderer plugin will not, which is not surprising. So I'm just going to copy this guy and go into the errors here. So this is basically the begin and end frame calls, right? So we'll go into the H, modify that first, and then we'll modify the C. So actually, let me, since I'm already here, right? Here's the begin frame. So we have delta time here. That's going to be frame data, and then the end frame is also going to take the frame data. We're going to forward declare the struct, just like we've done a bunch of other places. And then recopy this guy and go to our backend here and put in frame data. Gomi, thank you so much for the follow. I appreciate it. All right. Delta time. Place that with frame data. All right. Context frame delta time. Where are we using that, and why are we keeping a copy of it? Wow, are we even actually using this anywhere? I don't think we are. Yeah, I'm going to get rid of that. I don't think we need it. Eliminating unnecessary code here, folks. Always a good thing. Why is that still showing? Okay, I guess it's just tripping. Okay, so we have... Love to see people streaming code stuff. Yeah, I kind of like them too. I was doing AOC with Zig. Feels kind of good. Do you consider using Zig instead of C? I'm not familiar with Zig at all. I prefer C. I've been using C for a number of years. Actually, I used C++ for a number of years and decided I like C better. But no, I've not tried Zig. I've heard good things about it, but I've not tried it. I don't know that I would want to switch to that for something of this scale, given that I'm not all that familiar with it. Let's see. So I think, let me just go ahead and try building this. That should fix the Vulkan plugin. And I think the rest of what we have here is testbed errors. Okay, so all that is to be expected. So let's see, what are we dealing with? Application initialize frame data. So we don't need to do that. Actually, I'll keep that for application frame data, right? Because we still don't have that yet. All right, application updates. Need a version of this that uses the frame allocator. We really do need to resolve that, but for right now. Okay, so that's that we can't resolve yet because we don't have frame data that's application specific. We only have the engine version of it. Okay, so that's just referencing that same thing, that same array. Okay, so here we're actually doing a linear allocate based on our frame allocator. And we really should be using, application render. How does this meet the interface? I don't think it does. Let's see. Application types. Yeah, render, we should be using this. Testbed main. Application render. Application render. So yeah, this is using the new one. But since we're loading it dynamically, we're not actually going to see this issue until runtime. So that's something we'd have to definitely watch out for. So we'll go ahead and change this and the update actually to use the new structure. So we need our packet data there, or our frame data rather. So here we'll forward declare this, right? And then go into our game code and change, let me do update first. Let's go up here and do replace this with that, and then go down to render and replace delta time with that. And do we have our frame data? I don't think we do. So we need to include that. Oops, include core frame data, right? So we have access to that actual type. Because we're going to need that when we go to add our actual stuff here. So game state is also taking a copy of the delta time. See, this is the kind of stuff I'm looking to resolve, right? Because we have copies of the delta time everywhere, and we can get rid of all this stuff. So let's get rid of delta time out of the game state, because that's dumb, right? That's part of our frame data now. So we don't need that at all. Delta time, this is now going to come from the P frame data, delta time, right? So we've got that. Let's see what else we can resolve. So this is that array that we don't have a place for yet, so we can't resolve that just yet. Same thing for that. Linear allocator allocate. Did we remove the include for that? Probably shouldn't have if I did. Huh. Must have. Let's put it here. Include memory linear allocator. I'd like to get something where we don't necessarily have to know that it's a linear allocator. That might be sort of the next step of this, but for right now, I'm okay with it. So we have linear allocate. And this is going to be the game inst, which it was the game inst frame allocator. Now it's the P frame data frame allocator. And this is going to be the same thing to pass through the frame allocator. The build packet, this probably shouldn't be passing the frame allocator directly. We should probably pass our frame data to that as well. Which means we need to update our render view system. All right, I'm going to come back and do that so I don't lose track of what I'm doing. So for now, let's just change all of these over to use the P frame data frame allocator, and I'll come back and modify that when we're done. All right. Frame data world geometry. Okay, I don't have that. Just that one. And I think I think that's all the errors I can actually do for right now. Yeah, okay. So we're slowly whittling it down, right? Game keybinds. Oh, interesting. That's what we were storing that for. So the that is interesting. So we were using an accumulator here to basically build up time, to basically emulate a like a key repeat is basically what we're emulating here. Yeah, that's a complete hack. Should probably do that the right way. So the user data is the game instance, which is not going to have anything in it that I'm going to be able to use. Actually, no, that is, yeah, I was going to say, I thought that was an opaque pointer. Let's see. Yeah, I don't think I have anything here I can actually use. No. Okay. So we need a way to capture the delta time, or to query the delta time from the frame data without the frame data necessarily being provided in a callback, right? Because these are all bound functions, bound to keybinds. And so we don't really want to be passing frame data to every single one of these. Like, that's another parameter that we'd have to pass to every single one of these, which would kind of suck. So what I'm kind of thinking is we need some sort of globally accessible way to say, hey, what is the current delta time? What is the current game time? And be able to call it from anywhere in the application and not have to pass through some sort of state object. Or maybe we do have to pass through a state object, right? Maybe we do have to pass through the application in order to get that. I think I would actually be okay with that. Let's see. So here we only have the game state, right? And that does not have anything that we would need in the application. So let me look at the binding for this. Whoops. So that's the debug console here. Most of these things are taken in game instances, the user data, but not all. And I can see where that makes sense. Wait a minute. If I'm passing the debug console here as the user data, but I'm, this should be debug console. Right, because am I missing something here? We're adding these key bindings. These are the only things that, how did that not fail? I'll bet this never worked. I'll bet that never worked. That's another one of the great things in programming sometimes, is not when you look at your code and say, why isn't this working? But when you look at your code and you say, why is this working? So realistically, this should be this, which would not have access to that. More tests. Yeah, so I probably just never bothered actually testing this. And or I broke it sometime during the key binding refactoring that I did and just never checked it. Which is kind of poopy. And the irony of this is I was cold casting this to the wrong type here, but then passing it here, which is the debug console state, and it was still working anyways. And it never yelled at me for doing that. Ostensibly because this is a void pointer. If I had done this, it probably would have yelled at me if that was the wrong type. But in fact, that's probably what I should be passing there anyway. Which I think isn't this function kind of the same thing? Yeah, this is like the same thing. I'm just passing the void pointer through, right? I guess I don't have to do this, right? But we could be more explicit about it, right? That's probably better in the long run. Yeah, see, these are the same thing. So I probably should just be doing this so that we know exactly the type that we're dealing with on this side. So that we're reading the code, you know, we know exactly what we're dealing with. I could, I suppose, just do that, right? But I feel like this is a little bit easier to read. But that still doesn't resolve this sort of issue that we're having here with the debug console state not having a delta time. It does isolate the problem a little bit, right? But it tells us that we need the delta time somewhere that's easily accessible, and hacking it into the game state doesn't seem like the way to do it. Has to be global. I'm really trying to avoid globals, right? Globals have their space, but I'm trying to avoid that. So what I'm thinking I'm going to do is essentially make a do I want to make a, because I have the game state for these, but I don't have the game state for these. Maybe I should always just use the game state. Because the game state does have the debug console. So maybe I should just always use the game state instead of doing this. And then as far as that goes, any of these would always have the game state being passed through as the user data. And I could use that game state to access the delta time from the frame data. I think that's probably the way I'm going to fix it for right now. I'd like some sort of global accessor to do it, but I think for right now, this is going to be the less painful way to do it. And it'll avoid some hoops going through function calls and stuff. So I think that's probably the fix. So instead of passing debug console for these guys, I'm just going to pass game ins just like I'm doing everywhere else. All right, and then I'll go up here, and I'm going to say game, what is it? Application, user data, right? And then say, do I not have, what am I missing here? I thought I saw that was there, wasn't it? Was it not? It's the application state. I'm going to have to do a double cast here, which kind of sucks. that. The address of that. Yeah, exactly. Feels wrong with all those data being passed around. I agree. Definitely feels dirty. Because the thing is like, these are both void pointers, right? By design. Because the engine doesn't know what the application is up to, right? But it also means that I basically have to cold cast this. I really am not a huge fan of that. It's making me wonder if I should just store the game instance on the key map itself, which also, I'm not really a fan of it. I don't like having multiple copies of that stuff all over the place. What a rabbit hole I decided to jump down tonight. Awesome. You know what? Let's separate this out a little bit, right? This is kind of... Right, let's do this. And then we can say app here. And then... and then we can say game state pointer. We'll call this state, right? Is that, and then we'll say console state for here. Pass that here. Pass that here. Get rid of, all we actually need to do is say state debug console. Right? It's kind of a few steps, but at least it's cleaner than that line of code I had before. And if we need to access parts along the way of this, we can do that. So I think that is probably the way I'm going to do it for right now. Again, I'm not completely sold on it. I may think of something else while I'm offline, but for right now, that's what I'm going to roll with. So in this case, we have the console state, which is going to be passed here and here. And then the accumulated time we should be able to get from app engine state, right? Which we're going to have to, the engine state I think is a void pointer. Yep, it is. So that is actually a, oh shoot, I can't do that either, because that's opaque and only the engine knows about that by design. But since I do have that, I can actually just ask the engine for the state, the frame state, which is completely normal. Actually, if I do that, so I could pass that through here. Yeah, that's what I'm going to do. Okay. Because that'll be kind of a nice global way to sort of get it. Without actually having to use a global somewhere. Because, well, I can't even use a global somewhere. Because we have these opaque types that the rest of the application shouldn't know about, right? So we have engine create, engine run, engine on an event system initialized. So now we're going to have KAPI because we need that to be exported. We will return a constant pointer to frame data. And we'll say engine frame data get. And we need the this wants the application. I guess we could just use that. That's fine. Right? That should be fine. We'll try that out and see how that works. Not 100% sold on it, like I said. We need to forward declare this. So struct frame data and grab this, go over to engine.c. Put this after engine run down here. Actually, after this on the initialized. Then we can say game inst engine state. And now we actually have the type, so we can say engine state right. This isn't still static, is it? Ooh, it is. I technically could just call this, but I'm not going to do that because I want to get rid of that eventually. So let's do that. And oh, put this in the wrong spot. We want p frame data. Right, and I think that is, we need the address of that. So we want to return that. Okay. Now, let's just build that, make sure it builds. Oh, what did I do wrong? Did I type something stupid? Probably did. Oh, put the pointer. Yeah. I must be getting tired. Put the asterisk in the wrong spot. Okay. All right. So now we're in a spot where we can make that call. All right. So let's go down to our test case here. Do we have engine included here? No. Kind of sucks because we have to include engine. Not really a huge fan of that, to be honest. Yeah, I don't really like all the data passing around, but I have a feeling I'm going to probably attack this more than once. So I guess what I can do is I'll start with this one here. Engine frame data get, and we will pass the app. And that will give us const struct frame data p frame data equals and asterisk there. So now I should be able to say, actually, do I have, yeah, I did find that. Okay. Wasn't sure if I included that or not. No, that's actually IntelliSense being smarter than my code. So include core frame data. All right. Now I should be able to say accumulated time plus equals p frame data delta time. Let me build this. Okay, so this is how we're going to get it. So we can just request this from the engine now. I may make a convenience method that can be called from the frame data itself, like from the frame data file. For now, this is fine. I think I'm overthinking it at this point. All right, so that is the scroll hold, and then the only other ones I need to fix are these guys here. So this is called GameInst here. And then what I really want is just this delta time here. So I can get rid of that. So actually I just need to add that one line here. So I can do that there. And just change all these to use p frame data instead. Like I said, not 100% sold, but it's definitely a step in the right direction towards something that's a little bit more flexible. Let's see, one more. I don't like all this indirection that's happening either, to be completely honest. All right. Now, oh, the render view system. Did I? Oh, that's already a pointer. Oh, what a dingus. Okay. Anywhere where I'm using this, it's already a pointer. Let me just highlight those real quick. I don't need the address of those. I could just use the actual thing. Yeah, that's in a bunch of places too. I have to go back and fix that anyway. Okay. All right. Frame data. Okay. So now I think all these remaining errors all have to do with these world geometry things. So that is the next thing we're going to address. So our frame data is sort of our engine frame data, right? But our application is also going to have data that it needs to maintain on every single frame. And so what we're going to do as a result is we're going to say void pointer application frame data, right? And the application itself is going to be responsible for standing this up if it needs it. And it will also be aware of how to cast it and whatnot if it actually needs to be used even at all. So in our case, we're going to go ahead and stand one up just because we need one to facilitate a bit of a hack that we have in place. But it'll be a good example of something that you might use a application-specific frame state for, frame data for. Just to clarify this a little bit further, engine level frame specific data. Let's say current frame specific data, okay? And then this will be application level frame specific data. Optional, up to the app to know how to use this if needed. Okay. So we don't have to stand that up, right? We can just leave it as 0 and it'll be fine. However, we actually do need it. So in our application boot is where we're actually going to set that up. So let's see. So we have our state here. So we need some way to tell the engine how much memory we actually need. Because the engine is actually going to be responsible for allocating that memory. Because it is the only thing that has immediate visibility of its frame data. I can't see us doing it anywhere else. So we're also going to say a U64 app frame data size. Okay. And here we're just going to say the size of the application specific frame data set to 0 if not used. Right? And I do want to just take a moment to remind you guys in chat, this is a interactive stream, so I am keeping an eye on the chat. I just haven't necessarily had any questions or anything come up. But if you guys do have any questions or just want to say hi or something, feel free to jump into chat, and I will answer it as soon as I happen to see it. All right, so app frame data size. So I think in the testbed main where we're booting is where we're going to put that. So we're going to say config app frame data size equals size of, and then we need some type. So we don't actually have a type for this yet. And I'm thinking, where do I want to declare that? Could put it in game state. In fact, I think that's exactly where I'm going to put it. So I'm going to say type def struct testbed application data, application frame data. It's kind of a long name, but it should probably be named specific to that. And we do have this game state here that should probably be testbed game state. In fact, let's go ahead and rename that, right? Okay, so that's that. And here we're going to use testbed application frame data, right? So now that we have a size here to report to the engine, we go to the engine and engine run? No, engine create. We'll go here and actually initialize the thing. So let's see. We're setting our frame data here. So engine state p frame data dot application frame data equals, and we're going to k allocate this. Yeah, we're going to k allocate this. We're going to say game inst app config dot app frame data size. We'll do mem tag. What do we want to put that under? Game, I guess it is. Put it under game. That's fine. All right, so we'll go ahead and stand that up, but we only actually want to do that if this is greater than 0, right? Otherwise, we'll be explicit here and set this to 0. Okay. It technically already happens anyway during the allocate, but I'm just being explicit here in the code. Hey Travis, thanks for what you do. I've learned a ton from the Kohi series. So I really appreciate that. Thank you. That feedback definitely helps me a lot. And I really appreciate your support. So thank you so much for that. Definitely appreciate that. So we have the application frame data set allocated here. Let's go back to testbed main. So anything after boot, we should go ahead and be able to handle this. So as far as the application update goes, now we have the p-frame data. And if we look at that, we now have the application frame data, which we know the type of, which is testbed application frame data. Okay. So app frame data equals that. Oops. Okay. So we have no member frame data. Okay. I think IntelliSense is just flipping out here. So what we need in this is actually this world geometries setup. So let's look for wherever we're creating the world geometries. This is a D-array reserve for geometry render data, right? So we just need to set that up. So we need world geometries. I'm actually just going to copy this segment of text here and go to game state and add here. So it's geometry render data. It's pointer, right? Because it's an array of world geometries. So that is that. That's all we should need to do there. And now we can actually say, let's see. So we have the frame state. Yeah, p-frame data. Right? So we're setting that here. So we should just be able to say, not p-frame data, app frame data. We should have world geometries. Right. Okay. So now we should be able to say this. People like him deserve a medal. I don't know about all that, but I'm just hoping that, you know, people will find it useful, you know. I kind of wish that I had something like this when I was learning to do this stuff in the very beginning. So I'm hoping that, you know, folks will find this useful and learn from it. Along with all my mistakes and stuff I make, because I make lots, as you guys have seen. But that's sort of the way that it works, right? You try stuff and see what works, and if it doesn't work, fall back, find something else, fix your mistakes, and move on, right? Okay. So there's our world geometries. Let's go ahead and just grab this right here. We still have to resolve this to do at some point as well, but not going to worry about that tonight. Not going to get to it. So I guess I'll just do this cold cast here. So go ahead and get the app frame data. World geometries. All right, and I think there's one more down here somewhere, right here. Okay, save that and build. All right, so I think we have successfully built everything. I'm actually just going to do a clean and a rebuild just to make sure, because we changed a lot of code tonight. Changed 21 files worth of code. Right. Fingers flossed. Run it and see what blows up. All kinds of stuff. Cool. I think I saw an error up here somewhere. Dynamic allocator allocate. Whoa. Why did I hit that? Code casting app to a game state looks like a sneaky typo. Where did I do that? In those event handlers. You mean the key maps? The key bindings? This guy? Or was it up here somewhere? Code casting app to game state. Where did I do that? Was it in here? Let me see. So the game instance is user data. I'm not sure if this is the one you're talking about or not. Oh, the definitions of the bindings. You're talking here. Where I'm adding them? Like these guys down here? Oh, wait a minute. Also, that's a suspiciously large allocation. Sorry, typing on a phone. Yeah, I get that. Are you talking about this line here? Nope. Okay. I'm not seeing. I'm not seeing which one you're talking about. Oh, wait a minute. Wait. Game inst. Yeah, so that's the application. Oh, this. Oh, yeah, what the heck am I doing here? There should be that. That, I think, is what you're talking about. Yeah, okay. Ooh, yeah, that would have been gross. I think that's the only one I actually did that on. Get some sleep, man. Yeah, I know. It's been a long day. All right, so yeah, something's still foobar. So the suspiciously large allocation is because I allocated an arena of that size. So yeah, that one I'm not too worried about. Couple places in the file. Okay, let me look at some of these other things. So that's game inst state. That one looks fine. That one looks fine. These all look okay to me. These are the state. That's the states. Yeah, I think these all look okay. Game instance. Yep. Yep, that's the state. I don't see any more. The only one I see that was wrong was this guy. Unless I'm mixing something. Just below the one I fixed. Which one was that? That would have been down here on scroll hold. Oh, right. Oops, state. Yep, that was it. That one. Yep, okay. Cool, thank you for pointing that out. Yeah, I apparently do need sleep. Alright, so let me build this again. I don't think that's what's causing my crash, but... app frame data. Oh, so that's null. That's a null pointer. That's nice. Did I forget to... Oh, I know what I did. I know what I did. So this is... We set a breakpoint here. Right, so the application update is getting called before we actually boot, which is pretty sweet. Yep. So, technically speaking, we shouldn't be doing any of this if we don't have this. So if we don't have this, I'm going to return true because it's technically not a failure in that case. It's just, whoa, app frame data. It's technically not a failure, right? It sucks. Typed welcome got sucks. Yeah, welcome to the world of autocorrect. Gets me all the time, except usually what it gets me with is way, way more vulgar. Further along anyway. Provided allocator not initialized. Okay, so I'm guessing, did we not? Oh, okay. So apparently we are passing rubbish here somewhere. Let me get rid of all these things. I don't need those. Let's take a look at our call stack. Destroying Vulkan device. So it looks like it started up and like, wait a minute. Yeah, I still don't understand why. Oops. Let's see. Okay. Vulkan is the best API at the moment. I would not consider it the best. It's a API, right? Is it the most powerful? Yes, but it's also, it has a number of issues as well. But it's the one that everybody's going with besides DirectX, or of course Metal. But yeah, it's kind of becoming, it is the replacement for OpenGL. So yeah, I would say, I guess, de facto best. Let's see, dynamic allocator. Allocate aligned. Why is this failing? I want to see specifically what code is getting me there. Okay, linear allocator. Total size is 0. Really? So we're doing... Oh, wait, what? Why am I passing 0 here? Wait a minute. Total size. Yeah, frame allocator size. Okay, so it is this that's screwing up something. Watch me have not set it correctly. Yeah, that's 0. Oh, I bet I know what's happening. It's because this is happening before we actually boot the game, which is what sets the configuration. Okay, so I can't do this here. Right. So this actually needs to be moved to after the boot sequence, which is here. We'll do that before we actually flip the state over. I think WoW is mostly on DirectX on Windows. It's DirectX on Windows, and I think maybe Vulkan for... I don't know what they do on Mac, actually. But here we go. So we are up and running. So it looks like everything is working as expected, which is cool. So we have successfully basically refactored our update loop. And so now we actually have like a frame data structure that we can use and append things to. And we have an application specific one as well that we can configure as per the application's requirements. So it looks like we are good to go. That took a little bit longer than I wanted to get there, but oh, sweet. Looks like we aren't shutting down correctly. I'll bet I know why that is, though. I'll bet it's because, yep, the frame allocator is, well, why is that just, Why does it not like that? So launch again, escape, frame allocator. Oh, because I shut down the memory system at this point. So this literally does not need to happen. It was already wiped out by the memory system shutdown. Cool. Let me get rid of this. Run one more time. Bearman, thank you so much for the follow. Appreciate it. All right, so let me just load this up and shut down, and we're good. Okay, so that is going to wrap up the stream tonight. Got a little bit of a late start, got a little bit of a late ending, but nonetheless, I did kind of accomplish one of the things I've been meaning to do for quite some time, which was to refactor our update loop to actually have a structure that we can use with frame data that is valid, or that gets refreshed on every single frame. So now that we have that, we can actually jump forward next time with our, let's see, do I still have our scene notes? So next time we can actually kind of jump a little bit further with this scene stuff. So I'm going to go ahead, since this is working, do I have, am I on a branch? Okay, so I'm going to go ahead and push this now so that you guys have the code. Factored update loop to use frame engine and application specific frame data across the board. Right. Cool. So now that should all be pushed to, let's see. The repo. And that was a push to main, so we should just have it, right? Yep, here we go. So if we take a look at this real quick. 21 changed files with 285 additions and 134 deletions, so changed quite a bit. Chim Chim Charo, thank you so much for the follow. I appreciate it. All right, cool. Thank you guys. I really appreciate you guys, participating and jumping in and chatting and helping me get through the stream. So next time we're going to continue on setting up this simple scene. And, at that point, we should be able to set these things up and get some of this other code out of our game code and be able to move it over to the scene, have the scene manage some of this stuff for us. So that's what we're going to do on the next stream. Really quickly, I don't know if I'm going to wind up streaming tomorrow or not, but next week there will not be a stream because I have prior commitments that I have to attend to, and I will not be able to stream next week. So I will see you guys, if not tomorrow, I will see you guys the week after that. So with all that said, let me see if there's a channel I can raid real quick. Let's see. I'm going to raid Team Vosh once more. They are, for those of you who have not seen their channel before, we basically they're making an MMO from scratch, right? So it's kind of a huge project, right? And it's a 2-person team, and it's kind of interesting to see how they're going about it. They're kind of learning all the steps and everything that goes into an MMO, and what it takes to build something like that, and they're actually streaming their learning process along with it. So it's like kind of interesting, I think. So anyway, with that, I'm going to go ahead and raid now. So see you guys later.